Good morning. We have discussed about various options of cleaning and coating of the insulators. A new technology, that is a hybrid insulator technology, is being adopted by the utilities. So, we will look into the brief introduction part of these hybrid insulators, how these hybrid insulators will be of useful to the utilities. Particularly these hybrid insulators are made in a way to overcome the cleaning and coating aspects which earlier ceramic insulators used to be done. So, here the technology is the adoption of both ceramic and polymer material for the existing ceramic posts, particularly post insulators are being manufactured in the hybrid way, and the room temperature vulcanized coatings which were being done for the ceramic post insulators are being tried out with the hybrid post insulators. So, we will be looking into the basic introduction into the hybrid insulators, how the design aspects and how importance is this technology to be adopted. Presently many manufacturers and utilities are trying to adopt this newer technology. So, in the past we know the main options for bus post or support insulator in substations, that is in air insulated high voltage AC substations were either solid core porcelain or composite insulators up to 245 kV. In addition, room temperature vulcanized coatings were used at times to the solid core porcelain post insulator, mainly to improve the pollution or a contamination performance of this over a period of time. With the new developments have been made, particularly when it comes to the gas or foam filled hollow core composite insulators, as well as the large core diameters or solid core composite insulators. These are generally used in substations for the equipment and for the distribution component equipment which are housed. So, nevertheless requirements for extra high voltage and ultra high voltage AC installations in terms of length, mechanical performance, then creepage distance, the shed profile, contamination performance of this bushings or post insulators still present a challenge for all existing insulator technology, either it could be for the porcelain or the polymer technologies. So, realizing this need for high strength as well as low deflection under loads for applications such as earthing switches, disconnectors, reactors, bus bar support insulators. So, this has given a way for the development of a new type of insulators like the hybrid post insulators and so on, which are being used in the high voltage EHV or UHV substations. Here in the hybrid insulator technology, the concept is to combine the service experience which was earlier reported for solid core porcelain posts with the help of a proven pollution or a contamination performance of insulators with the silicon rubber housings. So, combination of both ceramic posts with the silicon rubber housing could provide a newer technology or newer insulator technology, where it could be of better help and service performance in the substations. So, the challenge was to provide mainly the reliable and also the cost effective solution. This combines the mechanical advantages like the solid porcelain and also the electrical advantages of silicon rubber housings or the liquid silicon rubber housings which are planned for high pollution requirements. So, the intention is to see that the adoption of both the technologies, porcelain ceramic or the polymer housing for better performance. So, many efforts were made towards this technology, improvements in this technology, and also in the production part, and design optimizations have been realized over the past several decades, and alternative solutions have been tried, have been developed and are being developed in terms of pollution resistance, the size of the bushings, the weight and so on. Here the main technology implemental aspect which have been undergone include the porcelain solid core post insulator with application of room temperature vulcanized silicon rubber coatings for the porcelain post insulators. The second is the solid core composite station post insulator manufactured with fiber reinforced resin tubes with silicon rubber housings. The first one being the porcelain solid core post insulator application of room temperature vulcanized silicon rubber coating. The second is solid core composite station post insulator manufactured with the help of fiber reinforced resin tubes with silicon rubber housings. So, there is a material which is being used to replace the porcelain. The third is the gas or foam filled hollow composite station post insulators mainly manufactured of fiber reinforced hollow tubes with again a silicon rubber housings. So, these have been improved and the technology is being tested and it is being used for some time. Apart from this, various other developments for larger core diameter, in particular to solid core composite support insulators have also been made, but these are limited by the production of the rod or the rod production process. So, in practice or practically solid core composite insulators are mainly applied for a system voltage up to 220 kilovolts, since they cannot achieve the required cantilever strength. So, this mechanical strength plays a role, and also the load deflection of a porcelain solid core post. So, that is the reason in practice solid core composite insulators were mainly used for up to 220 kilovolts. So, another approach has been using the hollow core composite posts with gas or foam filling. Besides the complex issues of the behavior of a filler, this solution also demands very large core diameters to reach a deflection under bending load similar to that provided by the solid core porcelain insulators. So, mechanical strength is of utmost importance for the long performance. So, hybrid outdoor post insulators offer a solution that combines the advantages of both porcelain post insulators and polymeric or silicon rubber post insulators, but without their respective disadvantages. This is how the hybrid post insulators came into the usage. So, these insulators were first developed in 70s. So, almost 50 years for application of 25 kV railway catenaries. So, this hybrid technology was tried out for railways or traction. So, by definition these hybrids or hybrid insulators are made up of a ceramic or glass core in the middle with a polymer housing and equipped with one or more metal fittings. So, this for 25 kV were developed. Later on these were tried for the post insulators and equipment mounting insulators for mounting the equipments in the substation. Therefore, this technology which started being developed in 1970s could also be applied for post insulators as mentioned. These post insulators or well as the hollow insulators or hollow core insulators, and for overhead line insulators what we normally call as long rod insulators. So, this has been extended for substation, transmission, and also for the equipment housing in the substations. So, there are advantages of going in for the hybrid technology. So, advantages of hybrid ceramic core insulators and some issues shared with the polymeric insulators have to be known. So, few are presented here. So, when you see the advantages, porcelain is the preferred solution for the mechanical bending, torsion and compression applications, and its high rigidity results in low deflection under bending load. A porcelain core is using the same production process as the porcelain insulators having sheds. Then porcelain housings offer excellent mechanical protection for porcelain. Polymeric housing, sorry, the polymeric housings offer an excellent mechanical protection to porcelain. Hybrid insulators, because of the combination of both the porcelain and the polymer, have lower weight in comparison to equivalent porcelain insulators with petticoats or sheds or the creepage part. So, here again the polymer housings allow for thinner sheds as well as greater creepage distances and provide improved long term pollution or a contamination flashover performance. That is one of the reason where even the transmission line insulators, that is the ceramic or glass insulators, are being replaced by the utilities in areas where contamination or a pollution flashover is a serious issue. So, here also polymer housings have better perform better thinner sheds as compared to the porcelain insulators. So, polymeric housings also protect the core from damage by short circuit arcs. This is one of the important aspect of a polymer housing. In case of any event or any damage to the polymer housing, only glazed porcelain is exposed, and this core material is not susceptible to moisture ingress or acid attack. So, several advantages are being shown here. The hybrid solution allows easy interchangeability of insulators at substations, on apparatus and also on overhead lines. So, the advantages going in for hybrid solution allows easy interchangeability. So, replacement of the insulators, bushings, post insulators, hollow core insulators, and also on the overhead transmission line is comparatively easier comparison to the ceramic or a glass type of technology. That is one of the major advantages of going in for the hybrid technology. This figure shows the process of the manufacturing for a regular post insulators and the hybrid process. Here as earlier explained in the ceramic manufacturing, ceramic insulator manufacturing, we have discussed about the production aspects, the manufacturing aspects of both the disc insulators as well as the post insulators. Here we briefly look into the process of comparison between the ceramic bushings or ceramic post insulators mainly and the hybrid process which is involved. So, you can see that for the ceramic process, cutting and grinding of this is done for the insulators. We have an assembly for fixing the metal end caps. This is after the initial process of the materials, making the molding aspects, then again after the firing and several process. So, the cutting of the extra portions of the insulators is done, then the metal fixtures are done here with the assembly as shown here. Then you have the testing of this finished insulator, post insulator. Here you can see the metal end fittings both the sides. So, here again the testing, electrical testing, mechanical testings as prescribed by the standards are being carried out. Once the equipment undergoes certain prescribed standards which are again routine or acceptance or type testings involving both mechanical, electrical tests as prescribed for a particular voltage level. These tested insulators or the lot of the insulator which have undergone the testing are again stored in a respective crates, and these are shipped to the required substations or the place where it is to be installed. So, this is again recap of the porcelain housing or a porcelain post insulator manufacturing process. So, here you see the hybrid process. It is mainly done with the injection molding similar to the molding of a polymer insulators, and once the injection molding is done, the insulators polymer sheds which are being kept from the assembly part, the polymer sheds are assembled on the ceramic bushings, and this undergoes the injection. After the injection molding, the materials are again tested for various electrical and mechanical aspects, and they are shipped to the necessary place where it is to be installed. So, after the testing. So, this is a process for both the hybrid as well as the porcelain technology where it is being used for the hollow core or porcelain insulators. So, how this is done? Silicon rubber injection molding, which we have discussed during the manufacturing of the polymer insulators. Here the silicon rubber housing is made up of high temperature vulcanized silicon rubber containing a high level of aluminum trihydrate. ATH is the filler and silicon rubber. So, in the ratio of prescribed 50 and 50 plus with some filler, additive filler, this housing is made of high temperature vulcanized silicon rubber. So, address the fact that silicones can temporarily lose hydrophobicity under continuous severe pollution or contamination environment. So, the temperature high temperature, high pressure multi-shot injection molding process which is being done, this guarantees that the rubber housing is fully bonded onto the adheres to the porcelain core. So, as mentioned earlier, the core of the insulator assembly is a porcelain. So, this core of the insulator inside is the porcelain, on that is the polymer or a silicon rubber sheds which are embedded on that. So, this high temperature high pressure short injection molding process guarantees rubber housing in full bonded onto the porcelain core, and the end fittings and the cement. Cement again is used for bonding these insulators. Here you can see the cement which is bonding the metal and the housing portion here, that is a ceramic housing on both the sides. So, it has to bond at the end fittings and see that mechanically it is stable. Again here we will not go deep into the various tests or the design aspects or the testing aspects. Again this technology being a newer one, design tests are basically to verify the suitability of design, materials and the method of manufacturing. So, as mentioned, since there are no specific standards for hybrid insulators presently, so the IEC 61952 and IEC 62217 are generally followed, where some of the tests recommended by these two standards are being used for the hybrid post design. So, tests include tests on interface and connections of end fittings. Here again similar to the standards prescribed, the thermal cycle pre-stressing tests, water immersion pre-stressing, Steep fronted impulse voltage test is an electrical test. Dry power frequency voltage test, again it is a withstand test at 50 or 60 hertz. Tests on shed and housing materials, here again being the polymer material, it has to be tested for the hardness. Accelerated weathering tests, tracking and erosion of the silicon rubber material, flammability test, and for the core, tests on the core includes water diffusion test, porosity conducted with relevant mechanical type tests. So, these are some of the design tests which with reference to IEC 61952 and 6227 are generally followed for the hybrid type of insulators. The mechanical test, again here the ceramic core of a hybrid post bears the mechanical load. This is transmitted to the core by the end fittings. So, therefore, since as mentioned earlier, no existing hybrid insulator standard is available for testing the mechanical properties also. So, again here the reference is made to IEC 60168 standard which is being used. Similar for electrical type tests, the standard electrical properties in accordance with the IEC 60168 are being followed for all the electrical type tests on these hybrid insulators. Likewise, natural aging and pollution performance or a contamination test as per the standard is referred, and for polymer material and for ceramic, these tests are being conducted where the standard references to 60168 for both mechanical and electrical tests. So, looking into the hybrid technology, the importance of this technology, we can have a brief information or the inference from the technology which is available. Here it is understood that for the AC applications, AC voltage applications, hybrid post insulators are available by which are being manufactured, and it allows the engineers to design high voltage AC air insulated substations using pollution resistant or a contaminant resistance and maintenance free insulators. This type of post insulators generally combines all the advantages of traditionally ceramic or porcelain insulators with those of the silicon rubber housing without any compromise. And this technology allows new type of post insulators for a variety of range to support applications in a new extension and replacement project. So, wherever the existing equipments, these can be replaced with the hybrid technology. So, it allows or it helps in the support applications for the changing replacement projects also. So, the design tests as well as the electrical mechanical type tests which were conducted according to the existing composite and porcelain or ceramic post insulator standards were being used for the present hybrid technology. And for long term natural aging and contamination performance, insulators are also being used with the available standards. So, a hybrid insulator test standard presently does not exist. It is in the draft stage, where the draft circulation, that is IEC TS 62896 on hybrid insulators both for AC and DC high voltage applications, which defines the definitions, test methods and acceptance criteria, is being approved for publishing in soon, or this will be used once it is standardized for the hybrid insulators and will be adopted for the testing of hybrid insulators, that is the post insulators which are used in substations and for the equipments. So, this standard helps industry to specify the products or the hybrid insulators which are being manufactured both in the country and well as internationally, and will be very helpful for the utilities for the reference. So, this is a general information about the hybrid insulator technology which is being presently coming up using the both ceramic as well as the polymer technology, which could in future also be extended to many other applications. Presently it is being used for the substation equipment mountings, post insulators and so on. With this the information about or basic introduction to hybrid technology concludes. Now we look into the summary of the entire course contents which have been discussed for this course, that is advances in transmission insulators. Some of the topics covered are being given here. So, we had started the subject with a brief introduction to the development of the power transmission, which is an important component. This gives the information about the present scenario of the power transmission, that is both AC and DC transmission. What is the present condition in the country, what is the future target which the country is progressing towards the power transmission for extra high voltage and ultra high voltage transmission. We looked into the important components of the transmission system which play a vital role, and the advancement of these components for the extra high voltage and ultra high voltage systems. We also discussed about the importance of insulation coordination. This particularly at extra high voltage and ultra high voltage conditions. So, insulation coordination is an important criteria for the design of line insulation for the voltages above EHV. So, the important parameters which come into the existence, the protection and the safety aspects had been discussed. We also looked and discussed about the manufacturing design and selection of insulator for transmission and distribution systems. So, what are the type of insulators to be used at a location depending upon the creepage, depending upon the number of insulators, and for the lightning aspects, considering the lightning switching and pollution aspects, how the selection of insulators have to be made for various environmental conditions, various polluted locations. So, this we have tried to discuss. We further discussed the importance of the ceramic, glass, polymer insulators in detail, where we stressed upon the manufacturing aspects of ceramic, glass and porcelain polymer insulators, their performance, the service experiences, how the technology to be adopted and which is the technology to be looked into, which is the better technology. Then we looked into the importance of the problem like contamination or a pollution. This contamination problem which is a very serious threat at the working voltages, that a point to be noted. So, at working voltages above 400 kilovolts, the contamination problem plays a major role. So, the design considerations have to be made on the basis of pollution or a contamination. So, at EHV and above 400, that is ultra high voltage ranges 765 kV, 800 kV, how the contamination flashover happens, the basic phenomena of pollution flashover, how it happens. So, what are the methods which are being used to tackle this problem, the utilities which have been using these methods. So, various techniques which have been evolved over the period, and what is the techniques which try to develop at the laboratory level have also been discussed. We also looked into the failure in the field, importance of reliability of the insulators, that is the 3 technologies, and also we looked into the importance of high voltage testings, and what are the type tests, acceptance or routine testings which are carried out for the various insulators, the importance of this testing, various test methods to be followed. Apart from that, there are newer insulators like the polymer insulators where still standards are being evolved. So, we also looked and discussed about the probable research activity or the standards which are to be evolved, some activity into these aspects, and the focus on this which has been attempted in the laboratory has also been discussed. Then performance of insulators, a newer type of test methods, and particularly for long performance or aging conditions, how the insulator perform in the laboratory aspects. This also we have tried to see the aging of polymer insulators in the laboratory for long period of time, both for different conditions, that is electrical, thermal electrical. Then we have also seen multi-stress arrangements which are being made, like the effect of UV, humidity, temperature, electrical stress. So, we have tried to look into the effects of these parameters, how the insulators perform in the multi-stress arrangement or environment based on some standard criteria, how it has been done. This also we have tried to look into this aspect, both under normal conditions and abnormal conditions like a low temperature condition and so on. Then we discussed the importance of the cleaning methods for the insulators, for porcelain, ceramic and also glass insulators. And we discussed about the coatings, special coatings for the three technologies, ceramic, glass and porcelain polymer insulators. So, how the coatings help in the better performance of these insulators in the field. So, lot of methods, techniques, procedures and also various solvents or solutions which are available try to discuss, and the importance of these coatings have been listed in the lectures. Apart from that, we also discussed about a brief introduction into the hybrid technology, that is the combination of the ceramic and the polymer technology, in particular to the substation bushings or the equipments where these porcelain housings earlier used to be used. So, with the help of the polymer or a silicon rubber technology, the sheds, whether sheds are of silicon rubber or a polymer material, and the core of the material being the ceramic bushings. So, this again one more the improvements like using the liquid silicon rubber is also being done for high voltage bushings or post insulators or the hollow core insulators at a very high voltage level. So, that also we try to use the liquid silicon rubber material on the ceramic bushing, so or on the composite material. So, several of these things have been discussed in this subject. Hope this lecture will be very useful for the practicing engineers, the students, as this technology in the country is being evolved, and the importance of insulation is of a prime importance, and design criteria for the insulation is of utmost importance, as the technology, even though is being evolved for last 100 years, the ceramic and porcelain, the recent polymer insulator which is being adopted for last say a decade or more, lot of information, lot of studies have to be conducted, as these are of newer technology, and being an organic in nature, the polymer insulator or silicon rubber insulator have a faster degradation comparison to the ceramic or a glass. So, this lecture feel that some important and useful discussions have been done. So, finally, I thank you all, and God bless you. Thank you.